In this lesson, we're going to learn about factoring trinomials. First thing you should do when you are factoring a polynomial is to factor out all the greatest common factors you can. You now need to factor your trinomial into a multiplication problem of two binomials. Let's look at a real number situation first. This will give you a better idea. I want to write the number 50 as the product of two numbers. So what options do I have? I could write it as 50 times 1. I could write it as 2 times 25. I could write it as 5 times 10. So you can see that I'm basically breaking up my number and writing it as a product, a multiplication problem. And that's what we're going to do now. With polynomials, though, you'll only have one correct pair. So we're going to start with x squared plus 6x plus 5, and we're going to show you how to factor that. So let's look at our x squared plus 6x plus 5. I've written out the two parentheses. So to remember, when we're done writing our two binomials, we should be able to multiply them back together to get the original polynomial. So that is why in the first location of both parentheses, I've written an x, because if I was to multiply those together, I would know that x times x should equal the original x squared. So now what we need to do is we need to come up with the last two numbers in the parentheses. And to do that, I need to know what multiplies together to be the number 5. Well, fortunately with 5, I don't really have any choices. I have the number 5 and times 1, and that's it. So let's go ahead and put the 5 in the end of this parenthesis and the 1 in the end of this one. Now I need to have either a plus or minus inside the parentheses. Well, I know that to get a positive 5 at the end, when I'm multiplying 5 times 1, they both need to be of the same sign. Whether they're both minus or both plus, they'll give me a positive when multiplied together. I'm going to go ahead and choose a plus, because now if I were to multiply these out and doing the foiling method, you would notice that the outside terms here would be 1x, the inside terms would be positive 5x, and that's what I have in my middle term here is a positive 6x. Let's take a look at a couple more examples. The first one at the top, x squared minus 3x minus 10. So again, I'm going to start by putting down my two binomial parentheses that I'm going to be filling in. Again, you'll notice I'm starting out here with simply 1x squared, so I know my first two terms are always going to be x times x. So now I move to the last two terms. I start with negative 10, and I want to find two numbers that multiply together that become negative 10. Now, to get a negative here at the end of my polynomial, it means that one of my numbers is going to have to be a negative number, and one's going to have to be positive, because the only way to make a negative when you're multiplying two numbers is if they are opposite signs. So when I put my numbers in for 10, I'm going to be adding them back together to see if I get a negative 3x. So let's go ahead and take 5 and 2. Now, according to my integer math, I'm going to have a negative 5x from these two terms. The outside term would give me a positive 2x. And when I add negative 5x and positive 2x together, I would get negative 3x. Now, there are some tips that we'll show you, but you'll notice really quickly that actually the difference between the 5 and the 2 was 3. And that's because when we learned our integer math, we learned adding opposite signs. You could simply subtract the difference, and whichever was the larger number, then whatever that sign was the sign of the final answer. Let's go ahead and do another one just to get this parenthesis portion down. Again, I'm going to write my two binomials for my trinomial. I have x squared in the beginning, and I know that x times x is going to be x squared, when I multiply this back together. Now in this case, I have 12. Now 12 has several combination of factors. So there's going to be a little bit of check and guess, trial and error sometimes to figure these out. So for example, I might say, well, let's see, how about 6 and 2? So I might put down 6 and I might put down 2. And again, because I know the signs have to be the same because this is a positive 12. So when I multiply 6 times 2, it has to become positive. So they're either going to be both plus or both minus. So if I put them together, let's go ahead and try both minus, because I see that there's a negative 7 in the middle, so it probably is minus. But then when you do your outside-inside terms, we get a negative 2x and a negative 6x, and that's not going to give us negative 7x. So clearly we're going to have to go ahead and try again. Let's try the numbers 4 and 3. So I'm going to go ahead and put a 4 at the end and 3 at the end. So leaving my two negatives, I do see again that negative 4 then times negative 3 would be positive 12. So that part still works. And then I have to do the important thing of the multiplying inside-outside terms. So if we take a look here, we get negative 3x. And these two multiplied together give me negative 4x. And when I add those together, I get negative 7x, which is what I need to have here in the middle. So some helpful hints to help remember what the signs are that you need in your binomials. Let's take a look at the first example here. X squared plus 6x plus 5 we determined was x plus 5 times x plus 1. So again, we notice the last term 5 was positive. So both signs in the parentheses must be the same. Two positive numbers multiplied together equal a positive number. The middle term is positive, so both signs in the parentheses must be positive. So when you add the middle terms together, you get a positive answer. Let's take a look at this one. X squared minus 7x plus 12. We just decided was x minus 4 times x minus 3. So again, the last term is positive, the 12. So both signs in the parentheses must be the same because two negative numbers multiplied together equal a positive number. The middle term is negative. So both signs in the parentheses must be negative. So when you add the middle terms together, you get a negative answer. Now let's take a look at the one that had a negative in the end. So x squared minus 3x minus 10 equaled x minus 5 times x plus 2. So the last term is negative, so the signs in the parentheses must be opposites, one negative and one positive. A negative number times a positive number gives a negative answer. The middle term in this case is negative, so the larger of my two factors must be negative. So when I add the middle terms, my answer is negative. If the middle term was positive, then the larger of my two factors would need to be positive. So when I, again, add the middle terms, my answer is positive.